Okay, so the rest of Algebra 1, Lesson 19, Part C, is called Roots. And you're going to see a symbol that looks kind of like this. That is called a radical. That symbol is called a radical. And just like subtraction is the opposite of addition, and division is the opposite of multiplication, taking the square root of a number is the opposite of squaring the number. And or just taking the root of a number is the opposite of raising that number to a power. So if we have, like in the previous section there, we were talking about exponents, 3 to the second power, is equal to 9. Because of that, we could say the square root of 9 equals 3. We squared it, now we square root it. So we did an operation to it, we do the opposite operation, it gives you the number you started with, that's 3. 3 to the third power is equal to 27. The third root, or we call it the cube root, of 27 is 3. Okay, this is asking what number do you use as a factor of 9 2 times? What number do you multiply by itself 3 times to get 27? Okay, and it's 3, because 3 to the third power equals 27. Now, in these things, these other parts have a name. That symbol is the radical. The number up here is called the index, and the number inside is called the radicand. Okay, now if it's a square root, then we don't write the 2. It's just understood to be there. That one's used so commonly we don't write the 2. If it's any other index, then we need to write it there. So if there's nothing written, it's a 2. Okay, we have the terms. We should probably do a couple of other examples. Let's try this one. Negative 3 to the third power. Alright, so I could write out negative 3 times negative 3 times negative 3, but also if you think about it, we know 3 is an odd number. That means we have an odd number of negative factors here. So you know the answer will be negative without writing that all out. And 3 to the third is 27. Alright, so what is the cube root of negative 27? That's just asking what number do you take times itself 3 times to get negative 27? Well, that was negative 3. Okay, so that's simplifying roots. Let's see. When your index is an even number, you could have a negative answer. Theoretically. Let's look at this. Negative 3 to the second power. What does that equal? Positive 9. So up here we're asking, what do you take times itself? What do you use as a factor 2 times to get 9? 3? It technically could also be negative 3. That is a root of 9, but usually whenever we do this, we are looking for the positive one. We call it the principal square root. Your book currently is just calling it the positive root. That's the one that they're looking for whenever you're asked something like the square root of 9. Even though technically negative 3 times negative 3 also equals 9, and we will use that in the future. Whenever we're simplifying these, it's always referring to the principal square root, which is the positive one. Now I believe we are done with Part C. We can go on to evaluating powers. Okay, now, for this part, well, we have a couple of examples here, and I know I intended to give you something right here, so I think we better just do a simple a little example first. If we have, you're supposed to evaluate xy. If x equals, I think we probably need to have a power here, xy squared. If x equals -3 and y equals -4. All right, so what we're going to do is use parentheses. Where there had been a letter, we're putting parentheses. That's to hold the number that goes in place of that. And then this one gets squared. So x is -3, y is -4. Now the order of operations, please is parentheses. There's nothing to do inside either of the parentheses. And then excuse is exponent. So the next thing is that. Keep the -3. -4 times -4 is a positive 16. And then we multiply. All right? So these are going to be a little longer. Use those parentheses. Your alternative to writing it with the exponents is to list everything out. That's just going to take a lot more space. So maybe I will show you that with one of these, but I definitely recommend just doing this. For this one, we have x squared z to the 3rd power y. All right, x is 2, z is 3, y is -2. Okay, there's nothing to do inside the parentheses. Next is the exponents. 2 to the 2nd power is 4 times 3 to the 3rd power is 27, and then times -2. Okay, then we multiply in whichever order you prefer. Okay, so I'm going to do 4. Just pretty easy to double things. So this is going to be negative because they're opposite signs, and this will be 54. And then we need to take 4 times -54. Again, opposite signs, the answer will be negative. And 4 times 4 is 16, and then we're adding to that 4 times 50, which is 200, so it's -216. And it's fine to write some of that out on the side. Okay, so again, the alternative, we could have written 2 times 2 times 3 times 3 times 3 times -2. You're welcome to do that. It's just, it is going to take a little more space in your boxes, but that is what these mean. 2 is being used as a factor twice. 3 is being used as a factor 3 times, and then -2. You'll get the same result no matter which way you write it, as long as you multiply correctly. Okay, one more example here. So again, I'm using parentheses as my placeholders, minus z to the 3rd. P is 1. M is -4, and z is -2. All right, so 1 times -4 times -4, because I'm just doing it as a factor twice. That is 16. Minus. Now, I can look at the sign in a little while. Okay, that minus is right there. 2 to the 3rd power is 8. 2 times 2 times 2 is 8. All right, and that negative, we have 3 of them. That's an odd number, so that's negative. So that minus, and then this part is the -8. Minus a negative is plus a positive. So we have 1 times 16 is 16, plus 8 is 24. Just be super careful with your signs. Do use parentheses. And have fun practicing these. I'll talk to you soon.